AB Calculus Note Card 73, volume off the axis. This is the 73rd video lesson in the series inspired by Stacy McMullen, formerly of Dallas Independent School District, who developed this note card system. This lesson 73 is an extension of lesson 72, which was using the washer method to find a volume. So we're going to see what happens here. Again, the same thing as in the lesson 72. You have a big R that you find. That's going to be your outside radius from the axis of revolution. And then you're going to have a little r, which is the inside radius off the axis of revolution. So the big R and or little r will be a binomial, either big T minus B dx or right minus left dy. So we're going to just look at this here, problem 1. And all of these, by the way, are free response or calculator problems. Let R, big R, be the region enclosed by this function here, y equals the square root of quantity x minus 1, the vertical line, x equals 10, and the x-axis. Find the volume of the solid generated when R is revolved about the horizontal line, y equals 3. Let's go take a look at the graph of that function. I hope you'll be able to draw this from your pre-calculus or other experience, but I put this here previously, and you can see what the graph of this looks like. And then if you add to that the function 3, y equals 3, you're talking about this volume here rotating about the horizontal line, y equals 3. So let's go ahead and make a sketch of that. For these, it's a good idea, in my opinion, to make a sketch of what's happening. So we draw this. We start here at x equals 1. We go to x equals 10. And the function is going to look like this. A square root function, and then we have y equals 3, and we have the horizontal line here. And so what we're looking at is the vertical line, x equals 10, and the x-axis. So we're talking about this area here. That's the area that we're rotating, and we're rotating that area about the horizontal line, y equals 3. Okay, so that's what so it's going to be a three-dimensional solid once that happens and the rotation occurs. So let's go ahead and so I'm going to get a skinnier line again. Okay. We have our big R. What's our big R? Well, it's going to be the difference between 3 and 0. So our radius is 3 minus 0 equals 3. That's our big R. Now, what is our little r going to be? Our little r is going to be this distance right here between the curve and 3. So our little r is going to be 3 minus the square root of quantity x minus 1. So the volume is going to be similar to that of note card 72, volume from A to B of big R squared minus little r squared dx, assuming a rotation about with respect to x. And then we have also the pi out front, not to be forgotten for rotation. So in this case, we have our volume is equal to pi, and we're integrating from x equals 1 to x equals 10, and then we have big R, which is 3, and we square, that's r squared, and we subtract out quantity 3 minus square root of quantity x minus 1, and we're going to square that, and we have dx. So now we have simply an entry into our calculator. We go get our calculator. I'm going to go get a page by pressing Control I, add calculator, and we're going to have pi, the right page here. Okay, now we'll do that again. Pi times the integral, we use the hotkey Shift plus. We're going from 1 to 10. And we're coming over here, parentheses, we have 3, that's our big R squared, minus, and I'm going to put in parentheses our little r, which is 3 minus the square root of quantity x minus 1. And we got to come out and square also the little r. And so there's the little r squared. And then we're doing this with respect to x, dx. And there we have it, 212.052. We don't see any types of limits or units or anything like this. So this is just going to be what our answer is for this one. Next, problem 4. A region R in the first quadrant only is enclosed by y equals x cubed and y equals cube root of x. Find the volume of the solid obtained by revolving the region R about x equals -2. It's a calculator problem again. You should know what these equations look like from pre-calculus, but in case you don't, it's a calculator problem. We can go take a look at it. We'll go Control I, add graph, and we're going to go place these pre-entered functions here. We have x cubed, there we go, and we also have cube root of x. And so this is this little gap here in quadrant 1. We're going to rotate that about the line, I believe x equals -2. And the intersection point is going to be at 1, 1. So let's go make a little sketch of what that looks like. So we have a XY coordinate plane. We have y equals x cubed right here like this. So this is going to be y equals x cubed, and then we have y equals cube root of x that looks something like this. So we put y equals cube root of x, and we have an intersection here at 1, 1. So this is going to be 1 here, x equals 1, and y equals 1. And we're trying to find the volume of the solid obtained by revolving the region R, and this is going to be our region R right here, about x equals -2. So we come over here to x equals -2. So we have this vertical line segment. So we're taking this volume, this area, and rotating it around this axis symmetry, x equals -2. And so we're going to want to have a function with respect to y for that. But to do that, we would take each equation respectively and solve for x. So if we solve this function, this cube root function for x, we're going to have x equals y cubed. And then if we take this other one here, this y equals x squared, that's going to be x equals cube root of y. And I hope that makes sense. It's going to be helpful to us. And so what we're going to have is our big R is going to be related to this function here, y cubed. And so big R is going to be equal to, we're going to take y cubed plus this distance of 2. So y cubed plus 2 is our big R. And our little r is going to be related to this cube root of y. So we're going to have cube root of y plus 2. So we got our big R and our little r. So to graph, to find our volume, we take our volume is equal to pi, and we're integrating from y equals 0 to 1. That's going to be the limits of integration related to 0 here at the origin and 1 up here. And we're going to take a big R, and big R is going to be y squared plus 2, and it's going to be big R squared. And we're going to subtract out little r, and little r is going to be cube root of y plus 2 squared, and that's going to be all dy. And so now we have reduced this to simply a calculator input problem. So we go to our calculator, get a calculator page, Control I, add calculator, and we start out with pi. The integral, use our hotkey, shift plus sign, 0 to 1. And then we have parentheses here, and then a second parentheses, because we're going to have to square this. Our big R is going to be y cubed. So we go to y cubed plus 2, and we square that, and then we subtract little r, which is going to be the parentheses here, a cube root of y, and we come over here, we're going to add to that 2, and then we come out and put squared, and then dy, and we take a second look here. We got big R squared minus little r squared. So this should be it. So for this one, we have an unfortunate consequence of getting a negative number. Now that'll happen sometimes. Let's go back and look at this. We took the y cubed first. Well, our big R is going to be this one here. Well, not really, because look at here is our big R is really going to be this one, right? Because it's going to be x equals cube root of y. So we got this backwards. This is going to be our little r, and this is going to be our big R. Now, this was a mistake. This was not intentional. But we have something that didn't work out. So what do we do? If we're doing a free response problem, do we just have to rewrite everything and put this back? No, we don't. Because if you make a mistake of sign, you can fix everything by making this, you can put absolute value brackets around this. If I put absolute value brackets, okay, I'm going to take care of that negative sign. And so we just say it's going to be, instead of negative 7.719, it's going to be positive 7.719. So this really was a mistake that I made in getting our radius radii reversed, but using this absolute value trick, we were able to fix that quite handily. So I hope that's helpful to you. Now, last problem, let big R be the shaded region between the graph of the square root of x plus square root of y equals 2 and the x-axis from x equals 0 to x equals 1. Set up the expression for the volume of the solid generating by revolving R about x equals 1. Again, I happen to have solved this equation for y, and to do that, what you have is cube root of y equals 2 minus, I said cube root, I'm going to say square root, 2 minus square root of x. And so if you square both of these, both sides of the equation, you get y is equal to quantity 2 minus square root of x squared. And that's what it's going to look like, at least the function solved for y. So we go here to our calculator, and we get a page, and we say add graph, and we're going to go to enter this equation here. There it is. We press this, and we get this kind of look right here. And we want to examine some key features. The first thing I want to do is examine what happens where y is 1. So I'm going to put tab 1, press enter, this orange line, and just take find the intersection point. So menu, analyze graph, intersection, left, right. So 1, 1 is our intersection. That's going to be helpful. Next, I'm going to go look at the values here. We see this curve, and what is that going to look like? Well, if we go to Control T and see what happens here, we see we'll scroll up here, when x equals 0, y equals 4, and then the curve comes down, and where x equals 4, y equals 0. So that's what's happening here. So let's go ahead and take our analysis and make a sketch of a graph of what's happening. So we have our xy coordinate plane, and we have our function here, y equals 4, x equals 4, and we have this function goes down like this. Let me just draw a little more, I think, of what it looks like. Does not have to be perfect. So the thing's going to look something like this. And we want to have, and the x-axis from x equals 0 to x equals 1. So here's x equals 0 to x equals 1. Okay, so, and we want to revolve around the line x equals 1. So we're going to go up here like this. So what we are is we're taking this shape right here, okay, this is what this shape looks like, and we're rotating it around the line x equals 1. And what happens is, if we look at this, we have this square here from y equals 0 to y equals 1, and then this sliver up here between 1 and 4. And so our big R is going to be this distance of 1, because that's our big R is always going to be 1 in each instance. So R is equal to 1, and we're going to have two different pieces no matter what that is. And then for the section between 1 and 3, for y is between 1 and 3, or 1 and 4, excuse me. Our big R is equal to 1, but our little r is going to be 1 minus this function here. So it'll be 1 minus, and what we're going to have to solve for that function for y is going to be the same, but we're going to have x equals 2 minus square root of y squared. And so we're going to have 1 minus 2 minus square root of y and squared that. So those are the pieces we have. So our volume is going to be the rotation of this square thing around here from 0 to 1. So we have pi times integral from 0 to 1 of big R squared, and big R squared is going to be 1 squared dy. Okay, and there's no little r available because this section, this volume, is really up against that axis rotation. And then we're going to have plus this little sliver here, and that's going to be pi times the integral from 1 to 4 of, we're going to have big R, so that's going to be 1 squared minus, we're going to have 1 minus parentheses 2 minus square root of y squared, and that's going to be dy. So these two integrals together. So it's a matter of entering these in a calculator, and we will have our correct answer. Okay, get another page, Control I, add calculator. So we have pi times the integral, shift plus sign, from 0 to 1, and our big R is going to be 1, and we're going to square that. Now we know 1 squared is 1, so that's kind of a moot point, but I want to technically put it in there anyway. We're going to get y and then we're going to come out here and add the pi times the integral from 1 to 4, and we're going to have 1 squared minus parentheses 1 minus, I'm going to parenthesize this again, 2 minus square root of y and then we're going to square that. Do we have everything here? Yeah, I think that should be right. Come over here, dy, and I hope that works out here. Hope we don't get an error message. No, we don't. Looks good. We get 5.75959. And rounding off to our 3 decimal places required is we'll get 5.7, and this 959 will make this to 60. And if you write either of these for your AP standards answers, either of these would be acceptable. So that's it. Again, a couple of these rotating around the uh, with respect to y. Not the easiest problems in the world, but just logically working out. When in problem 2, we ended up getting the negative answer, but we were fixed that with absolute value brackets. I hope this has been helpful to you. Good luck, and thanks for viewing.